Abstract state machines and large language models in multimodal cognitive architectures. As artificial intelligence continues to advance at a rapid pace, the pursuit of creating sophisticated digital humans has become increasingly prominent. These digital entities aim to replicate human-like behaviors, emotions, and interactions in virtual environments. At the forefront of this endeavor are abstract state machines, ASMs, and large language models, two powerful tools that hold the potential to revolutionize multimodal cognitive architectures in digital humans. This paper explores the synergy between ASMs and large language models, highlighting their roles in advancing the field and paving the way for a future where digital humans possess human-like finesse in understanding, interaction, and response. Abstract state machines, ASMs, are mathematical constructs that describe systems in terms of states and transitions between these states. Unlike finite state machines, FSMs, which are limited to a fixed number of states and transitions, ASMs offer greater flexibility and an abstract representation, allowing for the modeling of a broader range of systems and behaviors. This flexibility makes ASMs particularly well suited for representing complex systems, such as multimodal cognitive architectures in digital humans. Large language models, on the other hand, have emerged as a significant development in natural language processing. These models are trained on vast amounts of text data, enabling them to understand and generate human-like language. Their ability to capture the nuances and intricacies of language makes them invaluable components in the creation of digital humans with advanced linguistic capabilities. ASMs play a crucial role in the development of multimodal cognitive architectures for digital humans. One of their key strengths lies in their ability to handle diverse inputs. By representing different stages of processing various input types, such as visual data and textual context, ASMs enable seamless transitioning between modalities. This fluidity ensures a cohesive and integrated experience, allowing digital humans to process and respond to multiple forms of input simultaneously. Moreover, ASMs facilitate adaptive and dynamic responses in digital humans. By considering multiple inputs and their associated contexts, ASMs enable digital humans to generate responses that take into account the full scope of the interaction. This adaptability mirrors human-like decision-making processes, where responses are formulated based on a synthesis of various cues and contextual factors. Another significant aspect of ASMs is their capacity for hierarchical processing. The human cognition process is inherently layered, transitioning from basic sensory input to more abstract decision-making. ASMs, with their ability to structure processes hierarchically, can elegantly replicate this layered approach. Low-level processes can be dedicated to basic interpretations, while higher tiers handle more complex decisions, enabling digital humans to exhibit human-like cognitive processing. The integration of large language models into ASM frameworks is a key step in advancing the linguistic capabilities of digital humans. These models excel at understanding and generating human-like language, making them essential components when it comes to processing and producing textual content. Within the ASM framework, large language models can be activated whenever the system needs to comprehend or generate language. For instance, when a digital human receives textual input, the ASM can trigger the language model to interpret and understand the meaning behind the words. Similarly, when a response requires language generation, the ASM can utilize the language model to produce coherent and contextually appropriate output. By incorporating large language models into the ASM framework, digital humans can possess a level of linguistic expertise that closely resembles human communication. They can engage in natural conversations, understand complex language constructs, and generate responses that are both grammatically correct and semantically meaningful. The synergy between ASMs and large language models opens up a wide range of possibilities for digital humans. One compelling use case is a digital human capable of analyzing and discussing artwork. By leveraging ASMs to seamlessly process visual and textual cues, the digital human can understand the visual elements of a painting while simultaneously drawing upon its knowledge base to provide historical context, interpret the emotions evoked, and even discuss the techniques used by the artist. The integration of large language models allows the digital human to articulate its analysis in a way that is both informative and engaging, creating an immersive and interactive experience for the user. Another application of this synergy is in creating digital humans that can adapt to unexpected inputs and engage in clarifying questions for better understanding. By incorporating feedback loops within the ASM framework, digital humans can learn and adapt over time. If an input is unclear or ambiguous, the digital human can ask follow-up questions to gather more information, much like a human would in a conversation. This ability to seek clarification and adapt to new information enhances the naturalness and effectiveness of the interaction. While the integration of ASMs and large language models holds immense potential, there are challenges that need to be addressed. One significant challenge is the technical complexity involved in seamlessly integrating these two technologies. Ensuring smooth communication and coordination between the ASM framework and the language model requires careful design and implementation. Moreover, as digital humans become more advanced and human-like, ethical considerations come into play. It is crucial to ensure that the development and deployment of these entities are guided by strong ethical principles, taking into account issues such as privacy, transparency, and responsible use. Looking ahead, the field of digital humans is ripe for further advancements and research. Continued exploration of ASMs and large language models, along with the incorporation of other emerging technologies, such as computer vision and effective computing, can lead to even more sophisticated and immersive digital human experiences. Collaborative efforts between researchers, developers, and ethicists will be essential in shaping the future of this field. The synergy between abstract state machines and large language models holds immense promise for revolutionizing multimodal cognitive architectures in digital humans. By leveraging the flexibility and abstract representation of ASMs and the linguistic prowess of large language models, we can create digital entities that exhibit human-like finesse in understanding, interaction, and response. As we continue to push the boundaries of what is possible with digital humans, it is essential to approach this field with a balance of innovation and responsibility. The potential benefits are vast, ranging from enhanced user experiences to the creation of intelligent virtual assistants and companions. However, we must also navigate the challenges and ethical considerations that arise as these technologies advance. Through ongoing research, collaboration, and a commitment to ethical development, we can unlock the full potential of ASMs and large language models in shaping the future of digital humans. As we stand on the cusp of this exciting new era, it is clear that the synergy between these two technologies will play a pivotal role in bringing us closer to a world where digital entities possess the depth, nuance, and adaptability of human interaction.